So, good day everyone. I am Michaela Marie C. Ipil. So this time, we will going to tackle about measures of dispersion or variability. So, measures of dispersion or variability. If the measures of central tendency indicate where scores congregate, the measures of variability indicate how spread out a group of scores is or how varied scores are. So, in other words, the measure of dispersion helps to interpret the variability of data, to know how much homogeneous or heterogeneous the data is. So, the common measures of dispersion or variability are range, variance, and standard deviation. So, what is variability? Variability refers to how spread out a group of scores is. The terms variability, spread, and dispersions are synonyms and refer to how spread out a distribution.
So at this moment, let's tackle all about what is range and on how to get the range. Okay, so the range of a set of data values is the difference between the greatest data value and the least data value. Okay, so in the given, we have our given the set of scores of the 10 students from the 40-item test are 29, 30, 28, 27, 29, 36, 31, 27, 26, and 30. So these are the given scores of the 10 students. Since we have already know the formula of the range, which the range equals to the highest value minus to the lowest value. So what we're going to do is we're going to find the highest value in the given scores and the lowest value, then we're going to substitute it into our formula, which is range equals to HV minus LV. So our highest value in the given, we have 36, and our lowest value is 26. Then we're going to subtract. 36 minus 26 equals 10. Therefore, the range is 10. Okay, so the range is the most simple measures in the measures of dispersion or variability. As we can see, we solve the range very simple. We're going to just minus the highest value to the lowest value, then we get our range. Okay, so the set of scores of the 10 students from the 2 quizzes. These are another examples for us to be able to clarify what really meant by dispersion or variability. Okay, so the set of scores 10 students from the 2 quizzes. If we're going to solve the mean of the given group of scores in letter A, the mean will be 29.3. And in letter B, if we're going to solve its mean, which is meaning the average of the given scores, or the total of all the given scores divided by the number of scores, we get 29.3. Okay, see, so what does this mean? So the mean of group A is equal to the mean in group B. But Group A has the scores closer to the mean, while Group B has the lowest score and the highest score. That's what we mean of what is variability. Therefore, set of scores in Group B is more varied than scores in Group A. Or actually, we can say that, therefore, the set of scores in Group A is less varied in Group B. So, since we already know that the group B is more varied than group A, then we can say that this is how we identify or clarify measures of variability or measures of dispersion, since lately we have already tackled or discussed that measures of dispersion or variability is it indicates on how spread out a scores or a group of scores is, or how varied the scores are. So that's all. That's all for the range and that on how to identify measures of dispersion or variability. Then let's proceed to the next topic.
Okay, so let's go over with the variance. So variance is simply the square of the standard deviation. And for its formula for sample, we have x squared is equal to summation of x minus mean squared over n minus 1, wherein that specific sign is the weighted mean, and x is for the data entry, and n is the number of entries. Okay. So this is the given problem. So the sample set of scores of the 5 students from the 40-item test are 29, 30, 28, 27, and 29. And before we will get the variance for sample, we just have first to find its mean. So the formula is mean is equal to summation of x over n, wherein in the numerator part we'll just have to add the scores of our students divided by the number of entries, which is 5. There are 5 entries here, 1 2 3 4 5, and then 29 plus 30 plus 29 plus 27 plus 29 is equal to 143 over 5. So our mean is 28.6. So therefore this is our mean, the 28.6. So now let's go over with the table. Well, it consists x in the first column, and in the second column is x minus mean. Then the third column is x minus mean squared. Then in the fourth column is x squared. So in getting to x, you'll just have to put here the 5 number of entries, or mean or the 5 scores. And then these scores will just have to subtract it from the mean. So 29 minus 28.6 is 1.05. Then 30 minus 28.6 is 2.05. And the same way in these three. So now let's go over with the third column. X minus mean squared. So since this is already given, we'll just have to square each to get the answer in this column. So for example, 1.05 squared, then this is the answer. 2.05 squared, and this is the answer, and so on and so forth. So let's go over with the last column. So since this is our x, we'll just have to square it each. So 29 squared is 841, then 30 squared is 900, and the same way also in the 3 remaining. So now, since we already got our mean and its table, we will go now in getting the sample. So this is the formula. X squared is equal to summation of x minus mean squared over n minus 1. So our x minus mean squared here is this, the total of this column. We're in it is 7.3125. So that's why we substitute it here. 7.3125 over 5 minus 1. Then 7.3125 over 4. Then we'll just have to put square root from both sides so that we can cancel. So our variance is 1.35.
So proceed to measures of dispersion standard deviation. So the standard deviation of a set of numerical data makes use of the individual amount that each data value deviates from the mean. That is also the square root of the variance. And to fully understand, we have an example. 5 students take a test and their scores are 29, 30, 28, 27, and 29. First, write the scores 29, 30, 28, 27, and 29. Then label it X sub I. Second, we must get the mean. Using the formula, mean equals the summation of X over N. Then add the scores 29, 30, 28, 27, 29. over 5, and this will be 143 over 5. So divide, we will get mean equals 28 over 6. Next, go back to the table and get the x minus the mean, where our mean is 28.6. So 29 minus 28.6 equals 0.4. Then proceed with the other scores by getting the difference between each scores and the mean. After that, proceed in getting the square of x minus the mean. So 0.4 squared is equals to 0.16. Then 1.4 squared equals 1.96. So 0.36, 2.56, and 0.16. Then we will get the square of each scores. 29 squared equals 841. Then 30 squared equals 900. 28 squared 784. 27 squared 729. And 29 squared 841. Next step is getting the summation of the square of x minus the mean by adding the square deviations 0.16, 1.96, 0.36, 2.56, and 0.16. All in all, 5.2. Lastly, solve for standard deviation using the formula S equals the square root of the summation x minus the mean squared over n minus 1. So 5.2 over n, which is n equals 5. Since we have 5 score, 29, 27, 28, 30, and 29. So 5.2 over 5 minus 1 inside the square root. Then the result will be square root of 5.2 over 4 equals the square root of 1.3. Then the square root of 1.3 is 1.14. Therefore, the standard deviation is 114.
Everyone, let us continue our discussion. Okay, so in the previous discussion, we have learned that there are two formula in getting the standard deviation. These two, using the population mean, and second, using the sample mean. Okay, so like for example, if we have our population mean, which is 7, standard deviation is 2.983, and also if we have our sample mean 6.5, then our standard deviation is 3.619. So as you can notice, they are different, they are not equal, but close to each other. So why we do sampling, or why we take a sample? Because taking a sample instead of testing the population, the whole population itself, is easier and also cheaper. And how do we interpret standard deviation? Okay, so how do we really interpret standard deviation? So look at the sets of data shown in the slide. So these are Katie and Mike's score during a long test. And if we compute for the mean of both sets of data, you can get 201. But Katie's standard deviation is 37.6470, while Mike is 26.1017. So using that result, we can conclude that Mike tends to do better than Katie because his scores are more consistent than those of Katie.